All right, and welcome everybody to the Daily Space Weather. I'm going to try not to lose my you-know-what and rage out in today's video. Let's look at some imagery of the sun as we come at you with dial-up internet connection speeds. Hey, thanks, RCN! Doing a fine job today, a fine job. It took me like an hour and a half to make a 20-minute video today, so enjoy. Sunspot 2880 has been largely stable over the past 24 hours. No major solar flares. Coronal mass ejection warning continues. And we saw another one happen. Here's the viewpoint from Lagrange Point 1, the location of the LASCO C3. And you can see some ejecta coming out of the west side of the sun here. Does not appear to be Earth-directed. There's missing data. Maybe NASA's got RCN as an internet provider as well. Here's the colorized magnetogram for the past day or so. And you can see how stable indeed Sunspot 2880 has been. And as it moves out of the Earth-facing zone, it's more likely to produce major flares. The radio flux is only at, I think, 89 solar flux units. 91 maybe? Anyway, there's the one-year chart of the radio flux. The red line is the sunspot number. The black line is the 10.7. Space Weather Enthusiasts Dashboard reporting 87 for the radio flux. So having dropped down here, sunspot 2877 has set in the southwestern limb. So no space weather storms here or anything forecasted for the next 3 days. Again, that's a Space Weather Enthusiast Dashboard. Let's look at seismicity. There was at least one 6+ magnitude quake here, I think, over the past 24. Check it out, a very deep quake at Brazil, a 5.9 at nearly 600 kilometers estimated depth. Just scrolling up the list here, let us know if we've missed anything. Let us know in the comments if we miss anything throughout the month of smAshtober and throughout whenever we put up videos. There was a 5.9 in the mid-Indian Ridge there in the central Indian Ocean. So a couple of nearly 6 magnitude quakes there over the past 24 hours. Also a 5.1 at the Kermadec Islands. Pretty much minor levels of seismicity over the past 24. Volcanism is quite different. La Palma continuing to produce a 10,000-foot plume of volcanic ash and continuing to create some new real estate near the coast in the Canary Islands. Subanose Jima also exploding 12,000-foot ash plume over the Ryukyu Islands. Langila, 6,000-foot ash plume as it explodes over Papua New Guinea's Isle of New Britain. Popocatépetl, no volcanic ash observed in satellite. Fuego in Guatemala producing a 15,000-foot ash plume as it explodes. Sangay in Ecuador exploding as well. 19,000-foot ash plume there. Revenador, 17,000-foot ash plume over the other Ecuadorian volcano on the list. Sabancaya exploding. 24,000-foot plume of volcanic ash. Please don't pole vault the caldera. Please do visit our links. smAshomash.com has a link to the smAsho merch shop. The bestseller is the My Vaccination Status is None of Your Business HIPAA. Are you accountable? We're also on BitChute. And thanks to our YouTube subscribers, congratulations on realizing our channel exists. And don't forget to press like and subscribe if you enjoy the content. Thanks to all of our subscribers on YouTube. Cheers. Also, each and every one of you is invited to join the Smash Team. So if you head to smashomash.com/SmashTeam, or if you head to smashomash.com, you can link to the Smash Team. Smash Team gets all kinds of information nobody else gets to see. We've replaced Patreon with a vastly superior platform. So please cancel your Patreon if you are a patron. Cancel your Patreon. Go over, join the Smash Team. There are 2 tiers, $2.99 and $9.99 per month. If you want to know all of the information that we put out, join the gold level at $9.99 per month. If you want complimentary merch, pay up for an annual subscription. It's the best value by far. It's about a $40 coupon, essentially, for joining the Smash Team for a full year. Thanks to everybody who trusted us for a full year of content. We ain't going nowhere. Regardless of whether the internet shuts down or not, we'll figure out a way to put out the content. And welcome to the Neo-Renaissance. Smashomash.com. Find our links. Support the channel. Let's just say Google and YouTube have been less than stellar in their doing so. We're also on Twitch, twitch.tv/SmashoMash. Thanks to our followers over there. Install the free mobile app to know when we go live on Twitch. We'll be doing it later in the middle of recording this video for our meteorology segment. Check out the GOES magnetometer over the past 3 days. A major divergence happened right here, where the GOES 16 saw higher magnetometer readings and the GOES 17 saw lower magnetometer readings at the same time. For you new viewers out there, the N's and M's stand for noon or midnight time for the respective satellites. Anyway, now we're in a tight range here once again. Following the subsiding of a coronal hole high-speed stream, let's take a look at some more magnetic data. Here's the heliospheric current sheet, and we talked about the South Pole current sheet showing up. And there is a little South Pole current sheet there. This could grow, and the Earth could find itself in a South Pole current sheet. Basically, this is a period of geomagnetic indecision here on Earth. Anyway, there's the latest image. You can see that little bit of South Pole current sheet. It could grow, and the Earth could remain in that. It all depends on what happens in the southern hemisphere. It all depends on what happens in the Earth-facing portion of the solar disk. So here's a line of sight ecliptic plane field plot. And you can see the indecision here. North Pole polarity shown in green, South Pole polarity shown in red. Here's a line of sight coronal hole plot showing the sun's B field in blue. And you can see all these coronal holes causing some turbulence in the magnetic environment, which is exactly what you would expect as the solar cycle progresses. Keep in mind the data here is 44 minutes old from when we recorded the video, and the magnetic environment can change quite suddenly. We've got North and South Pole coronal holes, some North Pole ones crossing the equator over in this area. They're not too visible yet. There's a bunch of coronal plasma in between us and the coronal holes, but the magnetometer data shows it quite clearly. Anyway, this is 193 angstroms from the SDO, and you can see some well-defined South Pole-oriented coronal holes just rotating into the Earth-facing zone and just out of the Earth-facing zone down here. Likelihood of major solar flares is still there, folks. Sunspot 2880 is quite significant. It's beta-gamma class sunspot. We did see a C-class flare late last night and while we were doing show prep today. Maybe it actually caused an internet outage. I don't know. But in any case, that was quite a significant flare there. And that might have produced additional coronal mass ejections. We just don't know yet, as it took, again, like an hour and a half to simply produce this video. There's the GOES proton flux of the past 3 days. No relativistic particles have headed our way yet. Sometimes it takes only a half hour for solar protons to show up following a major flare. Next, we'll go to the real-time solar wind, hopefully. And there you have that. And you can see the subsiding here of this coronal hole wind stream. We still do have a bit of an elevated solar wind speed. It's still at about 400 kilometers per second. Solar wind density about just under 6 protons per cubic centimeter. The rest of that data is fairly unremarkable. So the KP index is only at 1. For you new viewers, the KP index is a measurement of global geomagnetism. You can see there were about 12 hours of geomagnetic unrest in the past 3 days, represented by those yellow bars. That's a KP4 geomagnetic unrest. Next, looking at 4 hours of magnetic data here, the magnetohydrodynamic pressure modeled in nanopascals by the Space Weather Modeling Framework. You can see most of the pressure here is in the magnetotail side, the portion of the Earth not facing the sun. And this is typical of what we see when we see a coronal hole wind stream subside. Low pressure on the sun side, high pressure on the magnetotail side as plasma gets reintegrated into the greater solar system solar wind. Next, looking at ground magnetic perturbations here modeled in nanotesla, which is actually magnetic flux density as opposed to magnetohydrodynamic pressure. And since there is a geomagnetic excursion going on, we show 4 hours of data daily. And you can see where magnetic pulses are occurring on the ground here, most likely. Some out of the Indian Ocean and Pacific Oceans. Next, looking at the Aurora Forecast. And we're expecting to see this subside here. And indeed, you can see the subsiding there. That's the subsiding of the coronal hole high-speed stream. So Aurora becoming less and less likely. with some weak solar activity. And we may produce another video later today in that there may have been another coronal mass ejection. So the coronal mass ejection warning remains in effect, folks. Solar flare warning remains in effect as well. Here's where stuff is in the solar system. Mars looking a little lonely. Let's advance this 1 week. And Mercury slated to swing past by 1010. The 10th day of smAshtober. Next, looking at a star chart. We've drawn in the ecliptic, which is the yellow line, the path the sun will take across the sky, as well as the galaxy. Yes, we've shaded and drawn in the galactic plane here at in-the-sky.org. Oh my God, the galactic plane, it's very scary. Don't worry, folks. If the sun isn't going to kill you, maybe the galaxy will. It's very scary. You should be scared and spooked. And let's do a smAshtober cosmology segment. Space. It's something to be scared of. Ask Ben Davidson. He's the moron who will try to convince you of it. Check it out. Here's one of these 3D images from the 90s. Remember these things? You stare at it and it turns into additional images. Yeah, you can store a lot of data in an image like this. And it all has to do with like unfocusing your eyes or something like this. It's the astronomy picture of the day. You can go check it out yourself at apod.nasa.gov. And I would read you the caption for the photo, but it's not able to be reached. Today we're not going to pick a random number at all. We're going to talk about massive radio galaxy Cygnus A, otherwise known as 3C405. Here are the X-ray outputs from it. Did you know that this galaxy is the second strongest radio source in the entire sky, second only to the sun itself? Yeah. It's located at about 530 million light years, and it's the strongest radio source in the entire sky. Our regular viewers may be familiar with Cygnus A. It's got massive radio lobes, and it's just a very interesting galaxy. When we view a galaxy from edge on, folks, it tends to have radio lobes that are visible. And here you can see some evidence of those radio lobes. I'm not going to break this down into different frequencies, again, because of internet problems, but 3C405 is absolutely one of the most interesting galaxies visible. Located in the constellation of Cygnus, obviously Cygnus A, the strongest radio source in the sky. Let's talk about additional galaxies, as it may not be commonly understood that galaxies don't just behave as vacuums, folks. They also behave as fountains. So they have outputs based on stellar jets, as every star seems to have polar jets, and the orientation of those jets determines the galactic output. In other words, if most stars are oriented perpendicular to the galactic plane, you will tend to have stellar jets that are perpendicular to the galactic plane, obviously. So here's an interesting article about this, and you can read about it yourself if you like, from scitechdaily.com. Part of the universe's missing matter found thanks to Very Large Telescope. It's looking more and more likely, folks, that all of the missing matter is just in intergalactic space, the space not within galaxies, but in between galaxies. And this makes perfect sense, as it is difficult to see things that are not illuminated at great distances, especially when they're diffuse. And we've got this galaxy producing a subgalaxy. So this quasar appears to have a jet which is producing a magnesium nebula. There you can see it right there in red. That magnesium nebula is like a satellite galaxy of this quasar known as GAL1. So maybe have a read of this article. Again, galaxies don't just behave as vacuum cleaners, folks. The supermassive radio sources at the cores of galaxies also behave like fountains. They have polar jets that are blasting relativistic particles straight out of the galaxy. The Milky Way has them. Look up Fermi bubbles if you've never heard of it. That's today's cosmology segment. And let's move the heck on before I become older and grayer. How about charging hazards? We don't see any satellite charging hazards at the moment. Let's go into the realm of electron flux. Here's the relativistic electron flux over the past year. That's reported by Solon.info. And we're seeing lower levels here. And we can expect to see an uptick in this now in the following day or two. There's the 3-day chart reported by the GOES 16 and 17 satellites. And you can see my forecast was right on from yesterday. Yes, I forecasted the electron flux. Good luck finding another space weather channel that's able to do such things. It's all about understanding the physics, folks. And I don't know. I'm not going to make a forecast for this. Anyway, there's the fork. The forecast is the green box, and the observation is the yellow diamond. If you've got a channel more accurate than us at predicting space weather, we would be more than happy to go check it out, because I don't think there is such a thing. Here's a diagram of Earth's Van Allen belts. Once again, congratulations on realizing our channel exists. And we hope you're not consuming a bunch of nonsense about things like the sun and cosmology and so forth. So here's the total electron content forecast. And we're seeing fairly organized bands of electrons here. No real surprise there. The most likely place to have massive GPS errors is around the equator at noontime. Here's another diagram of the atmosphere to show you where the F-ionosphere layer is. And we're seeing massive anomalies here in the ionosphere. So huge variations in the frequency happening in the ionosphere. There's a bunch of plasma interactions happening up there, high above your head at about 300 kilometers of altitude. And here's a visualization of it. You're looking at vibrational frequency here. And let's show you the anomaly map so you can see the anomalies that we're talking about. If you're not familiar with this, here's the anomaly map showing you departure in megahertz from the 30-day median. You can see low-frequency anomalies over northern Africa and the northern Atlantic Ocean, but mostly high-frequency anomalies shown in blue. Low-frequency anomalies are shown in red. Massive numbers of high-frequency anomalies there in the ionosphere. Perhaps a risk factor for major earthquakes. Keep in mind the resolution of this imagery is only 1 megahertz, which is probably not sufficient to use it for forecasting. If you've never read about our mission, head to smAsho.com/forum/mission. We are interested in all space weather variables that include predictive phenomenon. Predictive phenomenon. We're not interested in nonsense, fear-mongering, and grifting. We're interested in making humans more safe and understanding the predictive value and the physics associated with all this stuff. Anyway, there's the ionogram from 1015 and the anomalygram. Our meteorology segment featured me talking in a stilted voice. Did you check it out? smAsho.com/videos. If you're not seeing updates for our content, leave us a comment. Let us know that you're not getting notifications about our videos. I'm sure YouTube is telling you whenever we put out a video, though. I'm sure it's all on the up and up, folks. It's not fraud. It's totally not fraud, folks. I swear. I swear to God. So here's some imagery from El Teide, and you can see, looks like another filament eruption here. Could have been a coronal mass ejection. I don't know. We'll have to just wait until later to talk about that. Maybe we'll make another video. But that's the latest hydrogen alpha imagery from the ground-based solar observatory at El Teide, Spain. Here's the latest refresh of the intensitygram, and you can see it's taking all day. Just waiting and waiting and waiting. It looks like sunspot 2880 has degraded. And I don't have enough patience to wait for that to load. We're going to close out the video right here. Thanks again for tuning in, everybody. Don't forget to press like and subscribe if you enjoy the content. Pardon the lateness. We hope this video was released before like 10 o'clock in the morning today, Eastern Time. We'll see. And may that solar wind be at your back.